Hello, my people. I salute you wherever you are. Today is another day in Kenya, Africa, where, being the second day of the year, and in the promise I had made to have a video on the way the teachers can borrow a leaf from my presentation to show the students how the mathematical tables are designed and used. So in this video, I'll be looking at the most common tables for the secondary school fellows. And these are the logarithm tables, the anti-logarithm tables, the trigonometric tables, the reciprocal tables, the squares and square root tables, and the cubes and cube root tables. These tables, if we master how to use them, we are there to go in any question which does not require you to use a calculator or where you are directed not to use a calculator. So, my people, this video is actually designed for the teacher, but the learner can also go over it and just look at the notes part. Otherwise, the first part of the video is suggesting what the teacher should be having to prepare for this lesson. Let's go. So, these are my opening remarks. Hello and welcome back to Smart Memos. Today, we are looking into crucial tool for solving numerical expressions. That is, the mathematical tables. If you are a student preparing for exams or a teacher looking for fresh insights, this video is for you. Let's make maths easier together. So for the teacher, the lesson plan will look like this, or the layout. Of course, the subject is mathematics, grade level, form 3, secondary. Topic is evaluation of numerical expressions using mathematical tables. But specifically in this one, we are looking at the mathematical tables. All right. So I've just changed there that the topic is mathematical tables specifically. It's not really evaluation. And we expect the teacher to take about 80 minutes. That's roughly an lesson. The lesson objectives. By the end of the lesson, the learner should be able to understand how to use mathematical tables to evaluate logarithmic, trigonometric, and square root expressions, squares, cube roots, and reciprocals. Number 2, they should perform basic operations involving logarithms and antilogarithms. Accurately apply interpolation techniques for non-standard values in trigonometric and logarithmic tables. And finally, the last objective is they should be able to solve mathematical problems using the provided mathematical tables. So the resources the teacher will have is the mathematical tables, Kenya approved version. We have the chalkboard for those who don't have the whiteboard. Then for those who don't have markers for the whiteboard, they will have chalk for the chalkboard. And of course, the students are going to have scientific calculators for verification, although this is optional. The purpose of mathematical tables is to avoid you using the calculator. Introduction will take 10 minutes where you introduce the resources. And these are the mathematical tables. Okay. All right. So let's go on. Lesson activities begin with a brief recap of logarithmic and trigonometric concepts from previous lessons. I have videos on these things in this channel, so you can peruse this channel and you come across logarithms and trigonometric concepts. Pose the question, how can we simplify calculations for large or complex mononumerical expressions without a calculator? Introduce mathematical tables as an essential tool for simplifying these expressions, and you share the lesson objectives with the learners. The lesson activities, you should also highlight the relationship between exponents and logarithms and the trigonometry, sine, cosine definitions. These ones are in my area videos. Then we have building on this fundamental concept, we will explore how mathematical tables simplify complex. I don't know why the camera or the phone went off. So let's go from where we had left. So the relationship between exponents and logarithms I just mentioned before the phone went off. Building on this fundamental concept will help explore how mathematical tables simplify complex calculations. The recap will prepare us to understand how logarithmic and trigonometric tables can help evaluate numerical expressions effectively. Step 1, the teacher will take 20 minutes to use the logarithm tables, explain the basics, highlight the components of logarithmic table, the characteristic and the mantissa, explain how to locate the values in the table, give a worked example, evaluate, write the steps on the board, like 1, 2, 3, sum, 4, and logarithm solution. Let learners try a similar problem, evaluate. Step 2, explain basics. Explain how to locate values for angles in degrees and minutes. Introduce interpolation for non-standard angles. Worked example 2, write the steps on the board, locate. Interpolation adjustments for 22 minutes, sum, and then solution. Let learners try a similar problem, find. These examples are ahead of this video in the teacher's notes. Step 3, explain the basics, introduce square root tables and their use, demonstrate converting numbers into standard form for easier workup. So work the example 3, write the steps on the board, express, locate, adjust for solution. Let learners try a similar problem, find. So please note, these are notes for, these are just the highlight of the lesson plan, and they are specifically to guide the teachers. Step 4, provide learners with practice problems, facilitate group discussions as learners solve the problems, review the solutions together as a class, highlighting common errors and corrections. And finally, you have the summary. It takes 5 minutes where you recap the key steps for using logarithmic, trigonometric, and square root tables. Reinforce the importance of accuracy when reading and interpolating table values. Encourage learners to practice further to build confidence in using mathematical tables. Notice I've also included the reciprocal and the squares, cubes, and cube roots. And finally, in the lesson plan, the teacher is having the homework, evaluate, find, calculate, and then class quiz next lesson, which includes similar problems to assess the understanding. So now, let's look at the teacher's notes. That is the plan for the teacher. Let's look at the teacher's notes. For the teachers, first of all, ensure all students have access to mathematical tables. Encourage neatness and systematic work to avoid errors. Emphasize interpolation techniques as many learners find this challenging. So, mathematical tables. Mathematical tables, Kenya approved version, are standardized reference tools designed for students to simplify complex numerical calculations without a calculator. These tables typically include values for logarithms, trigonometric functions, squares, roots, and sometimes other mathematical operations organized systematically for ease of use. They are particularly helpful in solving problems where precise values are required but calculators are unavailable or not allowed. Mathematical tables are essential tools for evaluating numerical expressions. They provide pre-calculated values of mathematical functions such as logarithms, trigonometric values, and square roots, which simplify complex calculations. In this lesson, students will explore how these tables are organized and learn the practical skills to read and interpolate these values effectively. Number one, we'll look at the organization of the mathematical tables. We'll look at the logarithm tables, which are split into two components: characteristic, representing the integer part of the logarithm, and mantissa, represents the functional part located in rows and columns. Logarithms, used for simplifying multiplication, division, and exponentiation. The key formula to remember are the three laws of logarithm, the law of multiplication, the law of division, and the law of the exponents. And they are given there. The logarithm of a times b is equal to the logarithm of a plus the logarithm of b. The logarithm of a over b is equal to the logarithm of a minus the logarithm of b. The logarithm of a raised to n is equal to n times the logarithm of a. In other words, when you find the logarithm of multiplication, you add the logarithm. When you are multiplying numbers, you want the logarithms. When you are dividing numbers, you subtract the logarithms. When you have raised a number to an exponent, you multiply the logarithm by the exponent. Anti-logarithms reverse the process of logarithms to find the original value. Trigonometric ratios. Table lists values of sine, cosine, and tangent for angles in degrees and minutes. For non-standard angles, interpolation is required. So, that is it. Interpolation. If the exact value isn't listed, use interpolation. Find the two closest values in the table, e.g., for 4.5 and 4.6, and calculate the proportional difference for 4.52. Example, suppose you are finding the square root of 4.50, which is equal to 2.121, and the square root of 4.60, which is 2.146. The difference between the two is 0.025. All right. To interpolate for 4.52, 2.121 plus 0.025, the difference, you multiply by 2 over 10, which is equal to 2.126. The final result is that the approximate square root of 4.52 is 2.126. Let learners attempt a similar problem. Find the square root of 3.78 using square root tables. To find the logarithm of 4.52, locate the row for 4.5 and the column for 2, then interpolate for precise values. Trigonometrical tables organized by angles in degrees and minutes. Table provides sine, cosine, and tangent values. For example, for angles not directly listed, interpretation is applied to estimate values. We'll look at what is interpolation in detail. Square root tables present the square root of numbers. The numbers must be in standard form to locate values effectively. Interpolation is used for numbers between lists and values. 2. Adding a detailed example for each type of table, such as finding the square root of 4.52, will provide clarity and reinforce the concepts for the learners. Interpolation is a method to estimate values between two tabulated entries. Use the different column provided in tables to calculate an adjustment. Squares and square roots. Direct lookup for simple squares and roots. Break down numbers in standard form if they are less than 10 or more than 10. Accuracy and rounding. Follow the instructions for significant figures or decimal places in the problem. Use consistent loading to avoid errors. The common errors to avoid are misreading table values, forgetting to adjust for powers of 10, and incorrect interpolation. So now let's look at what is interpolation, guys, or the definition. Interpolation is a mathematical method used to estimate unknown values within a range of known data points. It involves finding a value that lies between two given values in a table or data set, assuming a linear relationship between the points. Why is interpolation needed? It is needed when a value we want to find is not explicitly listed in a mathematical table, such as logarithmic, trigonometric, or square root tables. Interpolation helps approximate the value by estimating it based on the closest available entries. Interpolation assumes that the change between consecutive values is uniform, that is, it is linear, and the unknown value is proportional to the difference between the adjacent known values. Interpolation formula. The formula for linear interpolation is interpolated value equals v1 plus x1 minus x2, x minus x1 over x2 minus x1 times v2 minus v1, where x is the target value, x1, x2, known values surrounding x, v1, v2, table values corresponding to x1 and x2. Example, find sine 35 degrees 25 minutes using a sine table. Steps, locate known values in the table. Sine 35 degrees 20 minutes is 0.5773, and sine 35 degrees 30 minutes is 0.5787. The difference between table values, so 0.5787 minus 0.5773 will give you 0.0014. Fraction of the interval to interpolate is 5 minutes over 10 minutes, which is equal to 0.5. Interpolation adjustment. Add adjustment to row a value. So you have 0.5773 plus 0.0007 is equal to 0.5708. And therefore, the sine of 35 degrees 25 minutes is 0.5780. Tips for interpolation. If the exact value isn't listed, find the closest lower and higher values in the table. Calculate the difference between them. Estimate proportionally based on how close the input value is to the lower number. Guys, there is something I've forgotten to tell whoever is concerned. The fraction of the interval to interpolate. The 5 minutes are the 5 minutes are the difference between the two values we have picked. That is 20 minutes and 30 minutes. All right? And then the denominator 10 minutes is the difference between those two intervals, which is 30 minus 10, you get 10 minutes. Okay? it's good to clarify there. Introduction. Logarithmic tables. A logarithm table provides the logarithmic values of numbers. Logarithms simplify multiplication and division into addition and subtraction. Use. Helpful in solving range numerical problems, especially in physics and engineering. On the other hand, anti-logarithm tables. These tables provide anti-logarithm, the reverse process of logarithms. They help retrieve the original number from its logarithmic value. Trigonometric tables. Trigonometric tables contain values of trigonometric functions, that is sine, cosine, and tangent, which are abbreviated sine, cos, and tan for different angles. The use is, sorry for the interruption. The use is essential in solving problems in geometry and physics, engineering, and astronomy. Logarithmic tables are used in scientific calculation to reduce computation effort. They simplify multiplication or division of range numbers. Example, the logarithm of a times b is equal to the logarithm of a plus the logarithm of a to base 10. Anti-logarithm tables used to find the original value from a logarithmic result. For example, if the logarithm of x to base 10 is y, then x is equal to the antilog of y. Trigonometric tables, widely used in calculating angles and sines in triangles, engineering designs for mechanical and civil projects, astronomy for celestial calculations. Logarithmic and anti-logarithmic tables. Pick a number and show how to find its logarithmic value using the table. Then demonstrate reversing it using the anti-logarithmic table. Trigonometric tables. Use a practical example. Find the height of a building using a given angle of elevation and the distance from the base. Conclusion. Highlight the importance of these tables in reducing manual calculation effort. Encourage the use of tables for faster and more accurate mathematical and scientific problem solving. Reciprocal tables. These tables provide reciprocals of numbers, that is 1 divided by a number. If the numerator is 1 and the denominator is any number, we call that expression a reciprocal. They help simplify division problems since division can be transformed into multiplication by reciprocals. The use is essential for calculations involving fractions, rates, or ratios. Square tables. These tables provide the squares of numbers. They simplify finding the square of a number without manual computation. Therefore, widely used in geometry, algebra, and physics to compute areas, solve equations, and handle quadratic calculations. Explanation for table use. The purpose is makes division simpler by converting it into multiplication using the reciprocal. Example, 2 divided by 9. From the reciprocal table, 1 over 9 is equal to 0.1 11111. And if you multiply 72 times 0.1111, you are going to get 7.9992, which is roughly 8. Square table. Purpose, quick reference for squaring numbers without manual calculation. Example, problem, calculate the square of 12 from the square table. 12 squared equals 144. Benefits of using these tables is that the first one is speed, accuracy, and convenience. In the speed, they eliminate the need for calculator in many cases. Accuracy, they reduce the chance of manual calculation errors. And convenience, they are especially useful for students and teachers during exams or teaching. Reciprocal tables, simplifying division problems. For example, 256 divided by 8 to 256. Instead of direct division, you use the reciprocal of 8, which is 1 over 8, which is 0.125. Okay, it was actually 256 divided by 8. There was an error there which I've corrected. So instead of direct division, use the reciprocal of 8, which is 1 over 8, which is 0.125. You multiply 256 by 0.125, you get 32. Useful for speed calculations and probability where reciprocals frequently occur. Square tables, find squares of numbers. Example, to find 12 squared, locate 12 in the square table to get 144 directly. Geometry application, used to compute areas of squares or solve Pythagoras theorem. A squared plus b squared is equal to c squared. And there is a whole video on Pythagoras theorem. Just go to my channel, Smart Travelers Memos. Although my good name is Mr. Medamo TK. Using reciprocal tables. Open the mathematical table to the section with the reciprocal values. Locate the number in the leftmost column and its matching value in the top row. If the table is segmented by decimal places, the intersection point gives the reciprocal value. Example, for 8, find 1 over 8, which is 0.125. Using square tables, open the mathematical table to the square value section. Find the given number in the leftmost column. Read across the row to get the square of the number. Example, 15, locate 15, and the square is 15 squared is equal to 225. Four, 32 divided by 9 from the reciprocal table. Locate 1 over 9. You get this one is 0.1111. Multiply this by 432 and you get 48. For the square, calculate the hypotenuse of a right angle with the side 6 and 8. Use Pythagoras theorem. 6 squared is 36. 8 squared is 64. From the square table, then 36 plus 64 is 100. And the square root of 100 is 10, which is the hypotenuse. For conclusion, reciprocal and square tables are invariable tools for quick and accurate calculations. By practicing with these tables, you can save time and minimize errors in mathematical computations. Keep exploring and mastering their use. Demonstrating conversion to standard form. This is a very important area as far as tables are concerned. So what is a standard form? Standard form is a way of writing numbers that makes them easier to work with in mathematical tables. It expresses a number as n is equal to a times 10 raised to b, where a is a number between 1 and 10, inclusive of 1, but exclusive of 10. B is an integer that represents the power of 10. Why convert? Mathematical tables are typically organized for values within a specific range. In G, logarithmic tables often work with numbers between 1 and 10. Converting numbers to standard form aligns them with this range, making it possible to locate their values in the tables, so that you can use either small numbers or very small numbers or very large numbers. Convert 452. Identify the value between 1 and 10 for A. Divide 452 by 100 so that you get 452 in standard form is 4.52 times 10 squared. Step 2. Locate 4.52 in the mathematical table under the logarithmic or square root section. Use the characteristic plus 2 from the exponent. In fact, you can get the characteristic positive 2 or the power of 10 by moving the decimal point of the number. Like for 452, the decimal point will move 1, 2 to come to 4.52. Example 2, converting 0.00452, you adjust to fall between 1 and 10. You see that number is very small. So we adjust it and we move the decimal point towards the right, 1, 2, 3. And that direction is negative, so that you have 4.52 times 10 to negative 3. So when you move the decimal to the right, the characteristic is negative. When you move the decimal to the left, characteristic is positive. Step 2, use 4.52 in the table and apply the characteristic negative 3 from the exponent. So always adjust the number to lie between 1 and 10. And that is what we did to 5.2. We moved the decimal from where at the end of 2 to 1, 2 steps, and we got 4.5. Convert 67.8. Step 1, adjust. Divide 67.8 by 10, you get 6.78 times 10 to the power 1. The decimal has moved just one step. To move from 67.8 to 6.78, the decimal point just moves one step, and that is why 10 is raised to 1. Locate 2. Locate 6.78 in the table and add plus 1 for the characteristic. Teacher's demonstration. Write these examples on the board. Walk runners through each step slowly. Emphasize the importance of adjusting the value without changing its magnitude. Runner activity. Ask runners to convert the following numbers to standard form: 324, 0.0789, and 12.4. Discuss the answers as a class. Key takeaway: conversion to standard form is essential for effectively using mathematical tables. Once in standard form, the values can easily be located or interpolated within the tables. Very important takeaway. So having now given those notes, may we look at the tables proper. And we'll start with the logarithm tables. A logarithm table provides the logarithmic base 10 values for numbers. Typically, the first column shows the base number, mantissa, while rows and columns represent the fractional part. And you can see the sample of a layout. And you can see now the logarithmic table layout there. Number, mantissa, columns, for decimal, right? So that is the layout. Explanation. Number n, the first column lists the base numbers starting from n, 1.0, 1.1, 1.2, and so on, usually up to 9.9. Mantissa, the logarithm of n to base 10. The second column provides the logarithm of these base numbers. All right. So mantissa, the logarithm of n to base 10. The second column provides the logarithm of the base number, integer part, plus the mantissa. Only the mantissa is listed since the characteristic or integer part of the logarithm can be determined based on the number of digits in n when you express the number in standard form. Columns for decimal digits. Additional columns give logarithmic increments for decimal parts n, 1.01, 1.02, etc. with their respective values. Use the first column for the main number and the decimal column to add increments. Interpolation. For values not listed, interpolation is used between adjacent values. Usage steps: identify the base number in the left column, move horizontally to find the appropriate decimal value, combine the characteristic with the mantissa to get the complete logarithm. For example, for n 1.23, find log 1.2, which is 0.07918 in the base column, and add 0.03 log 0.03, which is 0.0013 from the decimal column, resulting in logarithm of 1.23 to be 0.08048. Find the logarithm of 4.52, locate the row 4.5 in the table, locate the column for 2, the hundredths place. From the sample layout, 4.5 column 2 gives the logarithm of 4.52 is 0.6569. Result, the logarithm of 4.52 is 0.6569. If the value were 4.525, interpolation would be needed. And you do this. You look for the logarithm of 4.52, and then you look for the logarithm of 4.53, because 4.525 lies between. You get the difference is 0.0017, and you adjust, the adjustment will be 0.005 halfway, and therefore you multiply this difference by 0.5 5, and you are going to get 0.00085. So final value is 0.65775. An anti-logarithm table gives the base number for given logarithmic value. Sample layout is there. Then the table layout is like that. Mantissa log 10 value, log to base 10 value, and columns for decimal digits. So the mantissa, the logarithm to base 10 value, the first column lists the mantissas from 0.00 to typically up to 0.99. These are the fractional parts of the antilogarithms. Columns for the digits and the decimal digits. The additional columns provide antilogarithmic values for increments of the mantissa, 0.01, 0.02, etc. This allows quick reference to corresponding antilogarithmic value. Values. Each cell gives the logarithm of the combined base and common value. For example, the value at the intersection of 0.10 base low and 0.3 column is approximately 1.3183. Guys, remember, as you watch this video, you are supposed to be having the Kenyan version mathematical tables on your desk. Interpolation. For numbers that do not match the table exactly, interpolation is used between adjacent values. Usage. Split the logarithm into its characteristic, integer part, and mantissa, fractional part, which is found in the tables. Use the characteristic to determine the decimal placement. All right, e.g., 10 squared is equal to 100. Use the mantissa to look up the antilogarithm value in the table. To find the antilogarithm of 2.456, separate into two parts. Characteristic is 2 and mantissa is 0.456. Look up 0.45 in the base row and 0.06 in the columns. Value approximately 2.867. Combine with the characteristic and you get your answer is 286.7 as the number. Find antilog of 0.6569. Locate the row for 0.65 in the table. Locate the column for 6 in the hundreds place of 0.6569. From the sample layout, you get row 0.65, value 6 gives antilog 0.656 equals 4.52, and the result is approximately 4.52. Interpolation of antilog of 0.6569, antilog 4.47, antilog 0.657, difference is 0.04, adjustment 0.04 times 0.9 gives you 0.036. All right, and you find that the final value is 4.506. Trigonometric tables. Trigonometric tables provide sine, cosine, or tangent values for given angles in degrees and minutes. Sample layout for sine values. You can see the sample there. All right. And the tables are laid like that. All right. Angle. The first column lists the angle values from 0 to 180 degrees. Some trigonometric tables include additional values, e.g. from 0 to 360. Sin theta. The second column provides the sine values for the corresponding angles. For angles 30, 45, 60, and 90, these values are commonly memorized. So 30, 45, 60, and 90 ratios of sine you memorize. The third column lists the cosine values for each angle. At 90 degrees, cosine becomes 0, while at 0 degrees, it's 1. Tangent. The fourth column gives the tangent values. At 90 degrees, the tangent is undefined. Since tan 90 degrees is sine 90 over cos 90, and you know cos 90 is 0, and the division by 0 is not allowed. So it is undefined. Symmetrical functions follow symmetry. Trigonometric functions follow symmetry patterns based on angle quadrants. Sine 180 minus theta is equal to sine theta, etc. These patterns allow users to find values for other angles by using trigonometric identities. So we have 4 quadrants. Values for common angles. Some values are well known for certain key angles, like the sine of 30 degrees is 0.5, 45 degrees is 0.7071, and 60 degrees is 0.5660, or root 3 over 2, and the other one is 1 over root 2. Similarly, cos 30 is 0.8660, or root 3 over 2. Cos 45 degrees is equal to 0.7071, or 1 over root 2, and cos 60 degrees is a half, or 0.5. Further notes, trigonometric tables are often extended to cover angles in smaller increments, 0.1 or 0.5. For more advanced trigonometric calculations, a calculator or computational software may be used. Finding sine 30 degrees, 45 degrees. Locate the row for 30 degrees in the sine table. Locate the columns for 30 minutes and 45. All right. Interpolation. And you get that as the answer. So there, I've adjusted this to 30. This 30 degrees was not written properly, and adjusted everything, and you can see the way the layout comes. Reciprocal table looks like that. Reciprocal is 1 over x. Where x is any number. For example, to look for the reciprocal of 8, you just go to column 8 and you get 0.125, which is the same as 1 over 8. Square root tables. Square root tables are a tool used to find the square root of a number without a calculator. The tables are organized in rows and columns, where the rows represent the first part of the number and the columns represent the next number. To use the table, the number must be expressed in standard form as a decimal in scientific notation. For example, to find the square root of 4.52 you would locate the row for 4.5 and the column for 2. If the exact value isn't listed, interpolation can be used to estimate the square root. This involves taking the difference between two nearest values and adjusting proportionally. Demonstrating this with a specific example will help clarify the process. So this is the table of square roots, squares and square roots. Columns, first column integers n, second column squares n squared, third column square root of n. The range is normally between 1 to 100 in most tables, depending on the scope of the table. Decimal precision, they are always rounded to 3 or 4 decimal places. And normally, some tables have fractional common fractions like 1.5, 2.5 for more detailed work. Locate the number in the left column, read across to find the square value. For example, x equals 7. Go over and you find that 7 squared is equal to 49. Square root, locate the row 4.5 in the square root table. Locate the column 200s. From the sample layout, you get 4.52 is 2.125. Result, for interpolation, you get 4.5 and 4.6, because that is where 5.42 lies, and you find the answer is still 2.125 if you work. Find the square root of 4.52 using square root tables. Express the number in standard form. 4.52 times 10 raised to 0 already in standard form. Locate the value in square root table 4.5, column labeled 2 in the square root table. Cube and cube root table. Columns, the first column registers integers n, the second one is n cubed, and the third one is the cube root of n. The ranges of numbers is normally 1 to 100, depending on the scope of the table. Figures are normally rounded 3 to 4 decimal places, and additional numbers not in the table, you can do interpolation. Thanks for watching. I hope this session helped demystify the use of mathematical tables. Practice is key, so keep at it. If you have any questions or topics you would like me to cover, drop a comment below. Don't forget to subscribe and hit the notification bell for more exciting lessons. See you in my next video. Acknowledge the contributions of all those people. Bye-bye. See you later.